This is lesson 10.3, Operations with Radical Expressions. Your objective is to simplify sums and differences of radical expressions, to simplify products and quotients of radical expressions. Vocabulary. Like radicals. Radical expressions with the same radicands. Unlike radicals. Radical expressions that do not have the same radicands. Conjugates. The sum and the difference of the same two terms. You can use properties of real numbers to perform operations with radical expressions. For example, you can use the distributive property to simplify sums or differences of radical expressions by combining like radicals. Problem 1. Combining like radicals. What is the simplified form of each expression? Here we have 6 radical 11 plus 9 radical 11. We can use the distributive property to combine like radicals. Since radical 11 is the common factor in each term, we can factor that out, and we have 6 plus 9, the quantity of that, times radical 11, which simplifies to 15 radical 11. Here we have radical 3 minus 5 radical 3. We can identify that radical 3 is really the product of 1 times radical 3. So we can rewrite that as 1 radical 3 minus 5 radical 3. Now we can factor out the radical 3 by using the distributive property, and we have 1 minus 5 times radical 3, which simplifies to negative 4 radical 3. You may need to simplify radical expressions first to determine if they can be added or subtracted by combining like radicals. Problem 2, simplifying to combine like radicals. What is the simplified form of 5 radical 3 minus radical 12? Well, we know that radical 12 is the product of 4 times 3, so we can use the multiplication property of square roots to rewrite this problem as 5 radical 3 minus 2 radical 3. Now we can use the distributive property to factor out that square root of 3, and we get the quantity 5 minus 2 times radical 3, and we simplify that to 3 radical 3. When simplifying a product like radical 10 times the quantity radical 6 plus 3, you can use the distributive property to multiply radical 10 times radical 6 and radical 10 times 3. If both factors in the product have two terms, as in radical 6 minus 2 radical 3 times the quantity radical 6 plus radical 3, you can use the FOIL method to multiply as you do when multiplying binomials. Problem 3, multiplying radical expressions. What is the simplified form of each expression? Radical 10 times the quantity, radical 6 plus 3. Again, use the distributive property, so we get radical 10 times radical 6 plus radical 10 times 3. We use the multiplication property of square roots, and we can simplify this part to radical 60 plus 3 radical 10. Now we can simplify radical 60 by recognizing that 4 is a factor, and it's the greatest square factor of 60. By using the multiplication property of square roots, we can rewrite radical 60 as radical 4 times radical 15, and simplify that to 2 radical 15 plus 3 radical 10. Here we have the quantity radical 6 minus 2 radical 3 times the quantity radical 6 plus radical 3. We're going to use FOIL. So we'll do first radical 6 times radical 6, which gives us radical 36. Outer, radical 6 times radical 3, which gives us radical 18. Inner, negative 2 radical 3 times radical 6, which gives us a negative 2 radical 18. And then last, we have negative 2 radical 3 and radical 3, which gives us minus 2 radical 9. Now we can combine like radicals and also simplify. So we know radical 36 gives us 6. We have radical 18 minus 2 radical 18, so that gives us a negative radical 18. And then we know radical 9 is 3, so that simplifies to 2 times 3. Since 9 is a perfect square factor of 18, we can use the multiplication property of square roots to simplify radical 18 as radical 9 times radical 2. And when we simplify radical 9, we get 6 minus 3 radical 2 minus 6, but then the 6 minus 6 gives us 0, so we're just left with negative 3 radical 2. Conjugates. Conjugates are the sum and difference of the same two terms. For example, radical 7 plus radical 3 and radical 7 minus radical 3 are conjugates. The product of conjugates is a difference of squares. The product of the conjugate has no radicals. You can use conjugates to simplify a quotient whose denominator is a sum or difference of radicals. Problem 4. Rationalizing a denominator using conjugates. What is a simplified form of 10 over radical 7 minus radical 2? So here we cannot just rationalize the denominator by multiplying by radical 7 or just radical 2, because this is a difference of two radicals. So we actually have to use the conjugate. So the conjugate of radical 7 minus radical 2 is radical 7 plus radical 2. So we'll multiply both the numerator and the denominator by the conjugate. And we'll simplify this by doing 10 times the quantity radical 7 plus radical 2. And then the denominator, when you multiply those out using FOIL, you end up with radical 7 times radical 7, which is radical 49, which comes out to 7. And then when you do outer, you have radical 7 times radical 2, which is radical 14. But then we end up subtracting negative radical 2 times radical 7, which is negative radical 14, or minus a radical 14. So those two terms cancel out, and then we end up with the last terms, which is radical 2 times radical 2. So we're subtracting a radical 4, which is just 2. And we simplify the denominator to get 5. Now we can actually simplify the fraction. 10 divided by 5 is 2, so we have 2 times the quantity radical 7 plus radical 2. And we simplify the expression by distributing that 2, and we get 2 radical 7 plus 2 radical 2.